Hi everyone, welcome back to ICS 111, Intro to Computer Science 1. In this video, we'll be introduced to a new topic, arrays. We'll be looking at what an array is and why you would use one. We'll introduce the syntax of how to create an array and how you should visualize an array to better understand its anatomy. Managing and working with the data in an array can be challenging. We'll do some examples and see how to access and modify the data in an array. To start us off, what is an array? An array is a simple, fixed size data structure. Simple maybe should be in quotes, but in terms of managing data, an array provides basic functionality. This is the first time we are seeing these words data structure. A data structure is something that allows you to store and manage data. In other words, a way to store, retrieve, and change the data inside the structure. Once an array is created, the size cannot change. You can also think of an array as a variable that can store more than one value. All of the variables that we have been using up until this point only stored one thing. All the values in the array must be the same type. Most languages have some kind of array, but it may not be called an array. For example, Python. In Python, an array is called a list. So why would we want one variable that stores more than one value when we can just create individual variables to store the data? The short answer is to efficiently organize and manage related data. When you do use individual single-valued variables, they are considered disjoint. So you would have to create code for each specific variable that you have. So if you have many variables, it makes it that much harder to manage each of them. For example, if you wanted to store 5 exam scores, you can create variables for each score. Double exam score 1 equals 0 and repeat that 4 more times. But what if the amount of scores changes? What if instead of 5, you want to store 20 or 100 scores? Processing all those variables will become impractical. Doing simple things such as calculating the average or standard deviation, finding the max and min will be a headache. It is not impossible. A programmer can do it, but it is impractical because it is not an efficient use of a programmer's time. Also, the program will not be scalable. Scalable meaning if the number of variables change, the individual calculations also need to be changed. And this comes down to those variables being all disjoint. They are separate from each other. But when you use an array, instead of disjoint variables, you can create one array to store all the scores. So it will look something like this. Double array exam scores equals new double. And this is one way to create an array. There are actually 2 ways to create an array depending on what is known. Either you know how many values the array can store or the values themselves that you want to store. For approach number 1, you know how many values the array can store, meaning how big you want the array to be. The assumption here is you don't know the specific values because maybe the values will come from the user or maybe it will come from some outside source. But you do know how many values you want to be able to store in the array. To create an array using approach number 1, it looks like this. Element type, square brackets, give your array a name, equals, new, element type, and then in square brackets, the size. To break this down, element type, that is the data type of the values stored in the array. So what kind of data do you want to store in the array? It can be a primitive or it can be a class. So you can create an int array, a double array, a string array, or even a scanner array. The square brackets, that is the paired symbol representing an array. The array name, that is your array variable name. And then on the right side of the equals, you have the new. The new keyword is familiar. It allocates new memory for the array. And yes, an array is an object. Then you have the element type again, but this time in the square brackets, you put the size. The size is how many values the array can store, and the size must be an integer greater than or equal to 0. You can have an array size of 0, but that means you can't store anything inside the array. The second approach is when you do know the values you want to store in the array, and this is what the syntax looks like. The left side is pretty much the same, as that is the declaration of the array variable. This approach is actually a shortcut called the array initializer. Using the array initializer, you must complete this entire line. You cannot break it up between declaration and initialization. The element type, that is unchanged. That is the data type of the values stored in the array. And again, it can be a primitive or a class. The square brackets is the paired symbol representing an array. Array name is the array variable name. And then on the right side of the equals, you have curly brackets. Inside the curly brackets is a comma-separated list of values that you want to store in the array, and those values must be compatible with the element type. When you use approach number 2 with the array initializer, you do not explicitly state a size. The size of the array will be equal to the number of values listed in between the curly brackets. Alright, so far, there are 2 ways to create an array, depending what is known. Either you know how big you want the array to be, or you know the actual values you want to store in the array. Now, when you do name your arrays, because an array is used to store more than one value, the name of an array should imply that. That means name your arrays using plurals. For example, if you have an array and you want to store some names, use names with a S instead of just name. If you're creating an array of exam scores, use exams or exam scores instead of just exam or score. If you have an array of song lyrics, where each value in the array is one line of lyric, then use lyrics instead of lyric. When learning about an array, to get a better grasp for what they are, sometimes it's easier if you draw a mental picture to visualize what an array looks like, because what you can do with an array can get pretty involved. Recall visualizing a primitive variable from the beginning lectures. For a primitive variable, think of a box with a name, and inside the box is a value. So this primitive, int my favorite num equals 17, how you should go about visualizing that variable is some box with the name my favorite num, and inside the box is the value 17. So let's say we create a string array using approach number 2, meaning we know the values we want to store in the array. So it'll look like this: string array roster equals, and then in curly brackets, comma separated, each value we want to store in the array. So that's string ed, comma string Blanca, comma string Nikki. So there will be 3 string values stored in this array named roster. Now, based on how we visualize a primitive variable, you may think this: a large single box named roster with the names inside. It's not unreasonable to think that, but actually this is not accurate. To visualize a large box with the values in it is not reflective of what an array, or for that matter, what an object is. Visualizing an array is a little different because an array is an object. Some of the visualization will also apply to string, scanner, and even random. To get an accurate visualization of an array, we need to learn more about it. There are 2 components involved: the array variable and the array data. The array variable is how to reference the array data. So you should visualize a box that points to the array data. The array data is the actual data in the array, so those individual values. but to manage the data, the array variable is needed. To visualize the array data, think of a series of consecutive boxes that are glued together. Overall, it is a box that points to the first box in a series of consecutive boxes. Okay, so let's take this one step at a time. We have this string array called roster, and the array contains the values Ed, Blanca, and Nikki. The size of this array is 3 because there are 3 values listed in the curly brackets. The first component is the array variable. The array variable, in this case, will be a box with the name roster. The array data, which is the actual data in the array, will be the series of consecutive boxes that each contain a value in the array. So we'll have a box that has Ed, we'll have another box that has Blanca, and we'll have another box that has Nikki. The array variable roster, quote unquote, points to the first box of the array data. Now this term points, that is a term used when referencing the memory locations of objects. What is actually inside roster is the memory location of the first box of the array data. As of this recording, Java does not allow you to see what the actual memory location is, but that is okay because that specifically is not useful. If you learn the C programming language, you can easily access the memory locations of your variables. A memory location is a hexadecimal value. Okay, but coming back to our example, so far, here's the visualization of the string array roster. There are other analogies used to visualize an array, such as a row of houses, but when I demonstrate variables and objects in a face-to-face class, I have actual boxes that I use as props that I hold up. It is easier to hold up a box than it is a house. So this is the visualization of this string array roster. It is a box that points to the first box in a series of consecutive boxes. Now, why is it like this? It seems unnecessarily complicated. Well, this is reflective of how memory is managed in the Java virtual machine. The variable roster and the array data are stored in separate places in memory. That is why the roster variable contains a memory address of where the array data is. Now what? The question you should be asking yourself is, how do we manage the array data? How do I access or get the value Ed or Blanca or Nikki? What if I wanted to change the value of Ed to something else? How do you know how many values the array can store? That has to deal with processing the array data. At this point, we can't answer any of those questions. We need more information about the array. Now we're going to get a little technical and talk about the anatomy of an array, or the different parts. The term box that I use is just a layman or colloquial term. Each box is called an element, and an element is comprised of an index and a value. So those consecutive boxes that are used to store the array data, they have an index and they have a value. An index is a position in the array, and the value is the data. A value is stored at an index in the array. Now, I'm saying at an index instead of in an index because the index is like an address. When you say your address, you would say I live at and then your address, rather than I live in and then your address. So an array is made up of elements, and an element is comprised of an index and a value. Each element in the array has an index and a value. Now this word index, it should be familiar because we have worked with indexes using a string. An index is a position in the array, and it's zero-based numbering. An array of length n will have indexes from 0 to n minus 1, where n is strictly greater than 0. An array of length 0 will not have any indexes. Now this may seem very familiar, and it should. Internally, a string uses a char array to store each character in the string. This is why we are going to be seeing lots of similarities here. So each of those boxes that contain the array data are numbered starting from 0, and each of those boxes are an element. In our roster example, we can say the 0th element contains the value Ed, the first element contains Blanca, and the second element contains Nikki. Another way you can say it is the value stored at index 0 is Ed, the value stored at index 1 is Blanca, the value stored at index 2 is Nikki. There are 3 values, so we have indexes 0, 1, 2. Knowing this, we can now start to manage the array. The first thing that we will see is how to access the values in an array. To access a value, you need to know the index. If you don't know the index, then you can't access anything. Here's the syntax: array name, and then in square brackets, the index for the value that you want. And it must be an integer between 0 and length minus 1 inclusive. This notation, array name, square brackets, index, that's called array subscript or array index notation. And this is very important. This notation represents the value at that specific index. You can do whatever it is that you would normally do with a value of that type. If it's a string, you can call methods of the string class. If it's a number, you can use it in some arithmetic or comparison. If it's a Boolean, you can use it as a condition. So if I wanted to access the individual values in roster, roster 0 is Ed, roster 1 is Blanca, and roster 2 is Nikki. So that notation, array subscript or array index notation, you can take that and do whatever it is that you do with a string. You can use the length method, you can use the to uppercase, to lowercase, or even substring. But only indexes 0, 1, 2 are valid for this example. If you did roster 3, that doesn't exist. Or even if you do roster -1, that is not an index in the array. That does not exist. An exception will be thrown, and that exception is the array index out of bounds exception, which we'll talk about towards the end of the lecture. But for this example, there are only 3 values, so the valid indexes are 0, 1, and 2. Alright, so that's how to access or get the value in the array. What about changing or storing a value in the array? You would use an assignment statement with array index notation. So it'll look like the previous syntax, but with an assignment. Array name, and then the index equals new value. So what is the new value that you want to store at that index in the array? And again, the index must be between 0 and length -1, and the new value must be the same type as the array or a value that is compatible. So let's try an example. Let's say I wanted to change Ed to Edward. How would I do that? Take a few moments, pause the video. How would you change Ed to Edward? It will look like this. Roster 0 equals Edward. So that will overwrite Ed with Edward. How about this one? What if I want to change Blanca to Blanca in all uppercase? It would look like this. Roster 1 equals Blanca. But I think we can do better than that. How would you use to uppercase for this example? Take a few moments and pause the video. It will look like this. Roster 1 equals roster 1 dot to uppercase. Remember, you can treat array subscript or array index notation as that value. So roster 1, that represents the string Blanca. And what can you do with a string? You can call the to uppercase method. So you can say roster 1 dot to uppercase, the to uppercase method will return the uppercase version of itself, and we will reassign it at index 1. So that will overwrite the contents with the new value. Here's a common mistake when storing or changing values in an array, so be careful. You cannot do something like this. You cannot just say array name equals some value, or you cannot just say array name empty square brackets equals some value. Values are stored at specific indexes. You must specify an index in the square brackets. The only time the square brackets is empty is when you are declaring the variable name. The index can be an integer value or an integer variable. And I have this picture of an I there. You may use a loop increment variable if you are filling or processing the array, and that will come up. So we know how to access the values in the array, and we know how to change them. Another part of the array is this length property. The length of an array is how many values the array can store. Now, in the beginning of the lecture, I used the term size. The terms length and size are interchangeable, but not in code. When you're dealing with an array, in code, it is length. Now, this length does not and cannot change. It is fixed size. If it does need to change, you need to make another array and copy the values to that new one. To get the length of an array, the syntax is array name dot length, and that's it. The length is useful for things like looping through the array and performing some kind of error check. By the way, if it was not clear, the length of an array is an integer, therefore array name dot length is an integer. So while the terms size and length are interchangeable, in code it is not. In code, you have to do dot length. So I could say something like create a string array of length 5 or create a string array of size 5. Both of those sayings mean the same thing. But if you wanted to retrieve the length specifically in code, you have to use dot length. There is no such thing as dot size. So roster dot length, that itself will be 3. I cannot stress this enough. The length of an array is a property, not a method. The length of an array is a property, not a method. Now, why am I repeating this over and over? Because we have seen and used length before, but that was with a string. When working with strings, length is a method. So you take your string variable name, dot length, and then opening and closing parentheses. To get the length of the string, length is a method. To get the length of an array, length is a property. So it's array name dot length, and that's it. When working with strings, length is a method of the string class, and just with any method, you always have parentheses after the method name. But for properties, properties are not the same thing as a method. In this case, there is no parentheses when you deal with properties. It is just the property name. So to get the length of an array, length is a property. You just say array name dot length, and that's it. No parentheses. Here's an example of an integer array created using approach number 2. So I know the values that I want to store in the array. I have int array powerball equals and then some integer values. Since the array has been declared an integer array, the values in the curly brackets need to be an integer. So I have 25, 9, 5, 61, 17, and 32. That is a total of 6 values. Each of those values is stored at an index in the array. So 25 is stored at index 0 and 32 is stored at index 5. To get the length, you would take your array variable name, powerball, dot length. So that itself represents 6 because there are a total of 6 values, and those values are stored at indexes from 0 to less than 6, 0, 1, 2, 3, 4, 5. So with that, let's go into JGrasp and do some examples. Let's get some basic experience working with arrays by implementing the names and Powerball arrays from the slides. I created the program skeleton for a program called String and Int Array Demo. I did not implement the arrays yet because that has a different syntax to it, and I want to demonstrate typing it out in the video. If you want to follow along, pause the video and create the program skeleton you see. So what we want to do is create the names and Powerball arrays and do some basic access, modification, and print some values out. First, we'll implement the names array. The names array is a string array, and we do know the values. The values are Ed, Blanca, and Nikki. To create an array, you first start with the type, and that will be string. Opening and closing square brackets, that signifies an array. Space, you give your array a name, and in this case, it is names, equals, and depending on your approach, you will either start the new keyword or the array initializer. Since I do know the values, I will use the array initializer. So after the assignment operator, I'll do a pair of curly brackets and then a semicolon. Now inside the curly brackets, I will list the values that I want to store in the array, comma separated. The first value will be Ed, comma, space, and then I'll add Blanca, comma, space, and then Nikki. This is creating a string array named names with the values Ed, Blanca, and Nikki. Let's go ahead and compile the program to make sure it is valid Java syntax. I do not get any errors, so that looks good. Now let's continue on and let's create that Powerball array. The Powerball array is an int array. So we have int square brackets, the name Powerball equals, we'll get our curly brackets and then a semicolon. Now inside the curly brackets, we will list each of the integers, comma separated. So that's 25, comma, space, 9, comma, space, 5, 61, 17, and 32. Let's go ahead and compile to make sure it is valid syntax, and it is. All right, so we created two arrays, a string array and an int array. So what can we do with these two arrays? The first thing that I want to show you is the length. Length is a property of an array. So the length is accessed by array name dot length. Now this is an integer, so we can treat it like an integer. Let's go ahead and output the lengths of names and Powerball. Let's do a system out printf, and I will say the length of names is colon space. Here's where I'll put my format specifier. Length is an integer, so I'll do %d. Let's get a new line, and let's list names.length afterwards. Now notice, I didn't put any parentheses here. Length is not a method of an array. It is a property. So let's go ahead and compile to make sure that it is valid syntax. If you did put the parentheses like this, so if I add them and then compile, then I'll get an error. I'll get an error and it says cannot find symbol, and Java is telling me it doesn't know what this method length is. And that is because length is not a method of an array. So let's get rid of that parentheses, recompile, and it compiles okay. Now before I run, what is the expected output that I should get here? Since I created the array with some values, all I need to do is count how many values there are. 1, 2, 3. So the expected output should be the length of names is 3. Let's go ahead and run. And that's what I get. The length of names is 3. So let's go ahead and do that for Powerball. What I'm going to do is I'm going to copy this line because it is essentially the same. And I'll just change the specifics. So instead of names, I'll say Powerball. And let's also change it here as well. Powerball.length. For this line, I should expect 6 because there are 6 integers. 1, 2, 3, 4, 5, 6. Let's go ahead and compile and run. So we can properly get the length of an array, and the length is going to be very useful when you start to loop through an array and process the data. But for now, I just want to show you the length property. Now let's try to access a value in one of the arrays. Let's say I want to access the value ed. So let's come back to the program and give ourselves some working space. To access a value in the array, you have the array subscript or array index notation, and that is array name, and then in square brackets, in index. Now this is important because this notation, this is going to represent the value at that index. You can treat this notation as if it were that value. So let's say if I wanted to access ed. If I wanted to access ed, the notation is going to be names, and then in square brackets, 0. Ed is at the 0th index of the names array. So I can treat this as if it were the string ed. Now ed is a string, so I can do whatever it is that I do with strings. So I can print it out. If I do a system out println and put names index 0 in there, let's go ahead and compile. Compile's okay, and run, and I get ed. So names 0, that represents the string ed, and that's a string. So what else can you do with strings? You can concatenate a string. So if we do another print, and if I do names 0, and if I concatenate, let's concatenate this message, is the greatest sleeper in the world. And let's go ahead and compile, and then run, and I get the output as expected. So name 0, that represents the value at that index, which is ed. And since it's a string, what can I do with strings? Well, I can print it, I can concatenate it, and I can also use it in a printf, just like any other string. So if I wanted to print out not just my name, but what it looks like when I access that value. So what does that mean? Well, if I wanted to output this message, names 0 equals ed. If I wanted to print that out specifically using printf, it will look like this. System out printf. And so here's my format string. My format string is what I want the output to look like. My output I want to look like is names 0 equals, and here's where I'm going to use the format specifier. The format specifier will be replaced with the actual value. Since the value is a string, I will do %s, and then I will have a new line. End the format string, and then let's do names 0. Okay, just like that. This names 0, that is the array index notation referencing the value ed in the array. So this will replace the %s in the format string. Now this names 0, that's just the label. That's a label for my output. That's no different than saying something like banana equals and then the value of your variable. So that's just for output purposes. It doesn't actually access the value at index 0. This is just the label. So if I recompile and then run, then I get name 0 equals ed. So this name 0, that is just the label. So I can get or access the value in the array using array index notation. I say array name, and then in square brackets, I put some index. What I can also do is make a change. To make a change, you will use an assignment statement with array index notation. What I want to do is change ed to Edward. So I know names 0 is ed. So I want to change the value at index 0 to Edward. So it will look like this. I use array index notation to reference the value, and then I will use an assignment statement. I'll say equals, then the new value I want it to become. So names 0 equals Edward, that will store the string value Edward at index 0 in the names array. And if I wanted to verify the change, I can take this line. Let's take this line with the greatest sleeper. I'll copy it and let's paste it after the modification. I will recompile and then run. And then now I get the message, okay, Edward is the greatest sleeper in the world. So the fact that it says Edward and not Ed means that the value was changed because of this assignment statement. So array index notation is important as that represents the value in the array. You can treat this notation as if it were the value and do whatever it is that you do with that value. What about that Powerball array? So I have the Powerball array that has a sequence of numbers. What if I wanted to print that array out? I will need to access the value at each one of those indexes. So it would look like this. I'll come back to the bottom and let's give myself some working space and let's print out a message. System out print. And we'll say the Powerball numbers are, and then a space, closing quote, and then let's end the print instruction. So if I wanted to print each one of those numbers out, it would look like this. I'll say system out print, and then I will reference the value at the 0th index. So how many times do I have to do this? So since there are 6 numbers, I'll need to do it 6 times from indexes 0 to 5. Okay, so let's do that. I'll say print Powerball 0, and I'll repeat this 5 more times. So all I'm gonna do is let's take this line, copy it, and then let's paste it 5 times. 1, 2, 3, 4, 5. So I get a total of 6. But I'll need to change the indexes here. So I'll go 0, and then 1, 2, 3, 4, 5. And let's see what that looks like. Let's do a compile, and then a run. And oh, okay, so I wanted all the numbers on one line, and it kind of did that. So the Powerball numbers are, and then all the numbers are smashed together like this. Okay, so it's hard to read these numbers, but that is an easy fix. What I need to do is just concatenate a space after each number. So I'll come back to the program, and let's go ahead and concatenate a space here. And let's go ahead and let's copy this part and then paste it for the indexes 1 to 4. I don't need a space after the 5th one, but I'll probably need a ln here to end with a new line. So let's go and recompile. Recompile's okay, and let's run. And so now I get, okay, the Powerball numbers are 25, 9, 5, 61, 17, and 32. Okay, so that looks good. I can access a value in the array using array index notation, and that is array name, and then in square brackets, the index. I can change the value in the array by using array index notation with an assignment. I can get the length of an array by using the length property, and the length property is how many indexes are in the array. Now, you may have noticed that it was kind of tedious that I copy and pasted these 1, 2, 3, 4, 5, when in actuality, this is essentially the same print. Now, you should ask yourself, is there an easier way to do this? And the answer is yes, but we don't really know how to do it yet, because if you try to do something like this, let's say we try to shortcut it, and let's say we print this out, but instead, I would just want to reference the variable. So I think I'll be clever, and I will use the Powerball variable name and stick it directly in a print instruction. Now, if I do that, I can compile, and it compiles okay, but when I run, I get this as my output. And depending on your machine, it may be something different. You will have this capital I and then at, but this sequence of numbers and letters may be different on your machine. So now, what is that? This sequence of numbers and letters has nothing to do with the values that are stored in the array. This is a hash of the memory address, but that's not important in the scope of this class. What is important is that we cannot just stick the array name in a print instruction to print out the contents of the array. We will have to do something else. So let's go back into the slides and see what that is. To print the contents of an array, you must print each value individually As we saw, you cannot print an array by sticking the array name in a print instruction. You will get something, but that something is not meaningful. So what we need to do is use a loop to efficiently print an array. Printing each value in the array may be feasible if there are only a handful of values. But what if the array contains 20 or 50 or even 100 elements? It is better to use a loop. There are built-in methods in Java that allow you to print the contents of an array, but a loop gives you the most control over how to display the contents. So in order to use a loop, we are going to create a loop that counts from 0 to the last index in the array. In other words, create a loop that counts from 0 to less than the length, just like a string. Now here's a food for thought question. How would you print the contents of an array in reverse? Meaning, if the array was length 100, how would you go from 99 down to index 0? If the length of an array is 50, how would you go from index 49 down to index 0? Your solution should work for any array. What would be the initialization? What would be the condition? And what would be the modification? Keep that on the back burner and let's continue on. If we wanted to print the Powerball array, it would look like this. I'll create a loop that starts at 0 and goes to strictly less than the length. Now pay attention to the length. There is no parentheses there because in an array, length is a property. So it's just powerball.length and then semicolon. The modification will be I++, and inside the for loop, since each value in the Powerball array is an integer, I'll use %d as the format specifier, and the value is Powerball I. So you can see that using the loop increment variable inside the body of the loop is very advantageous. All the loop is doing is just counting 0, 1, 2, 3, 4, 5, but we are using that loop increment variable to our advantage. When I is 0, the array index notation will be Powerball 0. When I is 1, the array index notation will be Powerball 1, and that will effectively print out each value in the array. Now you may have noticed that there are some flags happening. It's not just %d, it's %02d. Now those 0 and 2, those are not values that get printed. Those are flags that affect the output. 0 is the flag for 0 padding, and 2 is setting the width to. So even though it is a single digit like 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 0, 1, 0, 2, 0, 3, etc. So instead of just outputting 9, it is 0, 9, 0, 5. %d itself would work, but since I'm doing the Powerball example, I would want to make sure it is 2 digits. All right, so with that, let's go back into the example and print out the arrays using loops. All right, so if we want to print an array or do any kind of array processing, we will use a loop. So let's go ahead and comment this line out because it is not useful. What I want to do is use a loop to accomplish the same thing as what these lines do. The length of the Powerball array is relatively small. There are only 6 elements in there. But what if the array was 50 or 100 elements? We would not want to create 50 or 100 lines of code just to print out each value when really all you're doing is the same thing over and over again. So we will use a loop to accomplish the same task. So let's come back down after this comment and let's start the loop. I will want to separate my output for this. So actually I will print a blank line here to separate what I did above with what I'm going to do now with the for loop. And then I will print another message and let's say printing Powerball array using a for loop. And then let's go ahead and print that same message as before. The Powerball numbers are, and I want to print out the Powerball numbers all on one line again, because that's how the balls are drawn when the numbers are revealed. Here's where I'm going to start the loop. Essentially, what I want to do is create a loop that counts from 0 to the last index. In terms of an array, that is from 0 to strictly less than the length of the array. So it'll be this: for int I equals 0, while I is strictly less than powerball.length, semicolon, and then I++ for my modification. Now all this loop does is just counts. It counts from 0 to less than length. I know the length is 6, so it'll be 0, 1, 2, 3, 4, 5, and that's the exact number of indexes there are in the array. But what we're going to do is use this variable I to our advantage, because at each iteration of the loop, I will change. It'll be 0, then 1, then 2, 3, 4, and 5. And that is exactly what we need to print out each value in the array. So all I'm going to do inside the for loop is just add a print, system out printf. And I'm going to use a printf for this because I actually want the digits to be displayed in a certain way. The format string will be a %02D and then a space. And that will be it for the format string. Now what this will do is format an integer value to ensure that it uses 2-character width and pad it with zeros. For those single digit numbers 1 through 9, it's actually 01, 02, 03, all the way to 09. So I want to mirror that in the program. After the format string, then I'll say powerball and then index I. So index I is important. That is the loop increment variable. So as I is changing at each iteration of the loop, so will the array access. The array index notation will also change at each iteration of the loop. So at the first iteration, I is 0. So this is powerball 0. And then it's powerball 1. Then powerball 2, 3, 4, and 5. And at each iteration, it's going to be printing that number. So let's go ahead and compile and then run. And let's see the output. Printing powerball array using a for loop. The powerball numbers are 25, 09, 05, 61, 17, and 32. And that is what I wanted to accomplish. But instead of creating individual print instructions for each number, all I did was use a loop. Use a loop that counts the indexes in the array. As the loop is iterating, use the loop increment variable to your advantage. Use it as the index to the array index notation. So this variable I is extremely useful. Not only is it the loop increment variable, but it is also the index in the array. Alright, so this is looping through an array. You go from 0 to strictly less than the length. But this is looping forward through the array from 0 to the end. What if I wanted to go backwards? What if I wanted to start from the end and then go to the beginning? What I want to do is loop backwards through the names array. So looping backwards, I want to start from the ending index or the last index and then go down to the 0th index. And I want to print out the names array backwards. If you want to try and give it a go and figure it out, pause the video. Alright, so to print the names array backwards, we essentially need to create a loop that counts backwards. So after this for loop for the Powerball array, let's give ourselves some working space. And let's also give ourselves some blank lines to separate the output. What I want to do is I'll take this println instruction, I'll copy it, and let's paste it 2 times. And then I will do my output message. So I'll tell the user print names array backwards using a for loop. So we'll know what it is that we're looking at for the output. And then I'll start the for loop. Now, to get an idea of what it is that we want to do, if I scroll up to the top here and just take a look at names array again. So names array has values Edward, because I changed it down here. So it's Edward, Blanca, Nikki. Edward is at index 0, Blanca is at index 1, and Nikki is at index 2. So what I want the output to look like is something like this. I want it to be names2 equals Nikki, names1 equals Blanca, and names 0 equals Edward. So I want the output to look like this. I'll go ahead and start the for loop. So for int I equals, and so I need to know where to start. I need to start at the last index in the array. So the last index in the array, that is the length minus 1. And I know how to get the length. That is names.length. And since I know that length is an integer, I can use it in computation. I can do names.length minus 1. And that is the first index that I need to start at. So names.length is 3 minus 1 will give me that 2 that I need to start at. So int I equals names.length minus 1. Okay, that will be my initialization because I want to start at the last index. Now, how do I know when to stop? So what is my condition? Well, I want to stop when I is 0. So the condition will be I greater than or equal to 0. Okay, it is not greater than 0 because the index can be 0. So I need to ensure that I goes down to the 0th index. So I greater than or equal to 0. And then my modification. Since I'm going backwards, I am decreasing I. So that will be minus minus. Close the parentheses and get my curly brackets going. So this loop, at this point, all this loop does is just counts. It counts backwards from the last index in the array to the first index in the array. And that first index is index 0. So names.length minus 1, that is the last index in any array, assuming the length is greater than 0. And then I need to go down to the 0th index. So that's greater than or equal to 0. And my modification is minus minus because I'm going backwards. Okay, so this loop, all it does is counts 2, 1, 0. And that's it. So what do I want to do at each iteration of the loop? I want to print out the name, but I want to do it in this way. So I'll do a system out printf. And here's where we are going to get a little fancy here. Recall that when I printed the names array up here, name 0 equals, and then some string format specifier, I knew exactly which index I was printing, and that was index 0. But if I were to put 0 in the format string, then it will always say 0. Now let me show you what I mean. So if I use that same format and say names 0 equals some string and then a new line, and then put names I, just like that, at each iteration of the loop, this names I, it will change to a different value in the array. So let's go ahead and compile and then run. Now look at down here. So it's print names array backwards. Okay, so names 0, already that is not correct. All of it says name 0, name 0, name 0. But there is a silver lining to this. If you take a look at the actual names, it is in reverse order. So I am getting Nikki, Blanca, then Edward. But the labels that I'm looking at is not accurate. I want this to be 2, then 1, then 0. But because I have the hard-coded 0 as part of the label, it's always going to be 0. So what can I do about this? Since this part is going to be changing, I cannot have a hard-coded number here. Instead, I need to use something that is changing. The only thing that's changing is that variable I. So you might think, oh, I'll just put I there, right? Well, if you do that, recompile, and then run, now it's just always going to say I here. But what is I? I is an integer. So you want to print not the string I, but the value of I. And the value of I is an integer. So what really you need to put in here is a %d for the integer specifier and then actually list the variable I at the end. So at each iteration of the loop, you also want to print out I along with the value at the ith index of the names array. So let's go ahead and recompile and then run. And now I get the expected output. Names index 2, that's Nikki. Names index 1, that's Blanca. And names index 0 is Edward. So now we can loop forward through an array. You make a loop that counts from 0 to less than the length, And you can loop backwards through an array. You start at length -1, go to greater than or equal to 0, and make sure the modification is I minus minus. All right, so these are some of the basic things you can do with an array. You can find the length, you can access a value, you can change a value, and you can loop through each index in the array. That's going to be it for this example. Let's go back into the slides and continue on with the lecture. So we have worked with integer and string arrays, but what about the other data types? For example, double, boolean, or char. It is essentially the same deal. You can create arrays of other types using the two approaches. If you know the values you want to store in the array, then you can use the array initializer. If you only know the size or how many values the array can store, then you would use approach number 1. Now, what if you don't know the values and you don't know how big to make the array? If you don't know the values, then you cannot use the array initializer. The array initializer is only when you do know the values. The only other option is to use approach number 1. Now, if you don't know how many values, then use a best guess, such as 100. There are other alternatives to an array that we will explore in a later lecture. Now, something to note are array default values. When creating an array using approach 1, no values have been explicitly assigned. So recall the approach number 1 is when you only know the size of the array. No values have been explicitly assigned. However, Java will assign default values depending on the type. If the type of the array is any numeric primitive, then the default value will be 0. If you make a char array, the default value is this minimum value of a char in Unicode. If you make an array of booleans, then the default value is false. And if you make an array using a reference type, meaning an object such as string, scanner, or random, the default value is this thing called null. Null means no object data. So keep this in mind when you do create arrays using approach 1. Even though you did not explicitly assign a value, there will be something in there depending on what the type is. Now, when you do start to process arrays, you'll be pretty much be using everything that we have been talking about lately. We will be using loops to go through each index. We use counters that represent the indexes in the array, and we will have some kind of accumulator. If you are building a string, so that's concatenating a string onto itself, or even adding numbers. We will also be using sentinel values to exit out of our indefinite loops. Before I go into the last example, I want to talk about array bounds. Array bounds refers to the valid range of indexes in the array. An array of length n has indexes from 0 to n-1, where n is strictly greater than 0. When using an index that is not between 0 and n-1, a similar exception to the substring method is thrown. If you recall, the substring method throws the index out of bounds exception. Arrays have a similar exception associated with them, and that is array index out of bounds exception. It is a mouthful. This exception can be avoided. You may not need to use try catch to catch the array index out of bounds exception. All right, so let's go into JGrasp and do our last example. For this last example, I want to demonstrate the default value that Java uses when you create an array of objects. It is slightly different compared to the other types. It is this value called null. Null means no object data. The object that I'll be using to demonstrate this is a string. So I'll create a string array and show you what the default value is. Java uses the default value when you create an array using approach number 1, meaning you only know the size of the array, not the individual values. So let's go ahead and create a string array. I'll start with string array, and I'll call this names equals new string, and then in square brackets, the size, and the size will be 5. So there will be 5 indexes, 0, 1, 2, 3, 4, and the length will be 5. Now, just to demonstrate this null, let's go ahead and create a for loop that will print each value in the array. So let's make a print instruction so that we know what we're looking at. Printing names array using a for loop. And then let's make the for loop for int I equals 0, I strictly less than names.length, I plus plus. So this will create a loop that counts from 0 to less than the length. And what I want to do is just have a print instruction. Null is not actually a string, so I'll just use a regular println. I'll do I, and then I want to concatenate a colon and a space, and then the names I here. So I want to show what the value is at each index. So I want to print the value of I here. So let's recompile and then run. And here we go. Okay, so I'm looping through each index in the array, and I want to print the value at each index. And you can see it all says null. Null, 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 null. Null means that there is no object data. Working with an array of objects is slightly complicated because you may need to explicitly initialize each value in the array. We can initialize each value in the array simply by doing an assignment statement. So a good initial value for a string is the empty string. So if I were to initialize the string at index 0, it will look like this. So names 0 equals the empty string, and that will initialize the value at index 0. But I could repeat this 4 more times, but that's pretty much the same instruction over and over again. So instead, we'll use a loop to do that, because what if the array was size 50 or 100? Then even more so, initializing each index is not practical. So we can use another for loop for that actually. If I comment this line out, I can just take this loop from before. Let's copy it and then come down to the bottom, and then let's paste it. Let's fix the indentation here. So this for loop, it's not going to be printing. It will just be initializing each element in the array. So it'll look like this. Names I equals empty string. So the first for loop, it will go through each element and print out null. The second for loop, it will go through each element again and initialize each element to the empty string. So if I wanted to see the result of the empty string, well, I can take this for loop again along with the output message. So if I copy these lines, and let's come back to the bottom of this for, and then paste it. Let's fix the indentation here. I want to make sure this output label is different so I know what I'm looking at. So let's say printing names array after initializing each value. And I actually don't need to change anything about this loop because I want to output what the value is. Let's recompile and then run. So now if I look at the output, okay, so the first for loop, it prints all the nulls, but after this for loop, it prints nothing. It looks like it's printing nothing, but actually it's the empty string there because this loop, this second for loop, is used to initialize each element in the array. So it no longer is null. There is some object data there. If you did want to initialize a value at a specific index, you can do an individual assignment. So you could still do something like this. Names at index 4, if I say Drake here, then this will assign Drake to the value at index 4. So if I recompile and then run, then here I can see, okay, at index 4, it has the value Drake. Now, another thing to note is that when you do this array index notation, I already mentioned that it represents the value at that index. You can think of each notation as a variable of that type. think of each element in this array as a string variable. The other way that you can create a string is by using the new string syntax. So instead of treating it like a primitive here with just a equals and then a value, you can also say new string and then the actual string that you want to put. So new string Drake, recompile. It recompiles okay, and then run. And then I still get that Drake at the end. Now, some of the last things that I talked about in the lecture was about array bounds. The bounds of an array are the valid indexes. If you do not put a valid index in the square brackets, then an exception is thrown, the array index out of bounds exception. So if I wanted to demonstrate that, if I come back to the program, after the for loop, if I did something like this, let's do system out println, and if I just do names and then in square brackets, -500. So it is quite obvious that there is no such thing as -500, but let's see what happens. If I compile, oh, it actually compiles okay. And if I run, then I get the array index out of bounds exception. It is important to note that the code did compile. It did compile even though I had a -500 here. The job of the compiler is to do type checking, meaning if you have a number between the square brackets, the compiler just ensures that it is an integer. -500 is an integer, so it passes the compiler. It is not until you run the program that Java will actually try to access index -500, and then it realizes, oh, there's no such thing as index -500. So then it'll throw the array index out of bounds exception. So an integer will pass the compiler, but when you run the program, if it is an index that is out of bounds, then an exception is thrown. Versus if you were to do something like this, names 1.1. So 1.1 is not an integer, so let's see what happens when you compile. Your program will no longer compile because 1.1 is not an integer. So just keep in mind this behavior. What goes in between the square brackets needs to be an integer, but Java does not actually try to access the value at that integer until you run the program. Alright, so that's going to be it for this lecture. It was an introduction to arrays. The next lecture will be a direct continuation. We will continue looking at arrays and apply them. If you have any questions, please let me know.